Okay, here we are on the Chapter 1 review, starting with problem 23. And for these problems, I don't think I'm going to rewrite the whole thing. You can just follow along on your own. But in problem 23, want the limit as x approaches infinity of 2x squared, and you have a 3x squared of the denominator. So if you notice, you have an x squared and an x squared. So as this function gets bigger and bigger and bigger, the x squareds are going to dominate, right? But they have a coefficient attached. So as you get really huge, you're going to have 2 times x squared on the top and 3 times x squared on the bottom. If you think of it, it would be kind of like having 2 trillion over 3 trillion. And you could kind of reduce that, and you'd get 2/3. And in fact, that is how you do this. If the exponents are equal, if the highest exponents are equal in the numerator and the denominator, then the limit as x approaches infinity is the ratio of the coefficients. In this case, that's 2/3. And that also means that this would be a horizontal asymptote, because as x goes to infinity, the function gets closer and closer to 2/3. Okay, so let's look at number 24. We have x going to negative infinity here. And so we're looking at what happens as the x values get really, really, really small. So what's going to dominate as we get to like negative 1 million, negative 10 million? Well, these x cubes are going to dominate. And they're going to dominate with negative numbers. So you could think this would actually be like negative 3 trillion and negative 2 trillion. So we'd have a negative in a very large negative number in the numerator and a very large negative number in the denominator. So that'd be a negative over a negative. So it's going to end up being positive, and we use the ratio of our coefficients. So it was 3 halves. 3 halves. Okay, ratio of our coefficients, and we looked at our sign. We're going to negative infinity, and it was negative and negative, so it's going to be a positive 3 halves. The next one, number 25, again we're going, x is going to positive infinity, x is going to infinity. So what's going to dominate? Well, it's going to be the highest exponent that dominates. And in this case, it's x to the 4th in the numerator. So the bigger we get, the bigger our numerator gets. And as we keep getting bigger and bigger, our numerator gets way more bigger and bigger than the denominator. So really, as we just keep going to infinity and infinity, infinity, this number overall is going to get bigger and bigger and bigger. So this limit does not exist. When you're talking about limits at infinity, it's customary to write why it doesn't exist. So it does not exist infinity, because it's going to get bigger and bigger. Okay, let's look at the next one, 26. Again, we have, oh, it's the same function. So we have x to the 4th in the numerator. We've got a 3x cubed in the denominator. So x to the 4th is once again our dominant exponent. And we're going to negative infinity. So what happens as we get to like negative 1 million and negative 2 trillion? Well, this is an even function. So no matter what, this is going to have a positive output. But it's going to have a positive output in the numerator divided by a negative output in the denominator. So even though the numerator is dominating, the numerator is going to be getting bigger and bigger and bigger, and this is going to be getting bigger but not as fast. This is still going to be negative, right? That 3x cubed is going to make sure that as we get really big, the numerator is always, I'm sorry, the denominator is always negative. So this is always going to be positive. This is always going to be negative as we get big. So we're going to get does not exist, negative infinity. Okay, so these do not have horizontal asymptotes. So when a function goes to infinity, there's no number, so therefore there's no horizontal asymptote. Okay, let's look at 27. And 27 is another piecewise function. And, oh, there's an error. Hopefully I'll correct it before I hand you the papers. But the first part of the piecewise function should be x is less than 1. Anyway, they want to know some limits here. So what's the limit as x approaches 4 from the left? Oops, 4 from the left of g of x. We have two intervals involving 4. Which one brings us in from the left? This one does, right? This one goes from 1 to 4. Maybe skip that over. From 1 to 4. So we're coming toward 4 from the left. Now we don't ever reach 4, but from the left we can say what the function intends to do. So that's going to be the limit as x approaches 4 from the left of x squared plus 2. That's going to be 16 plus 2. It's going to be 18. So the next one predictably asks what's the limit as x approaches 4 from the right of g of x. So as we get to 4 from the right, well, we're coming from here, the function 3x minus 10, right? So actually I probably drew that in the wrong place. I think it goes down here. 3x minus 10. And so as we're coming from the right, what are we getting to? We're using 3x minus 10. So that equals 12 minus 10 equals 2. Right? Because as we look at 4 from the right side, it's defined by 3x minus 10. Okay, and then even more predictably, the final question is, what is the limit as x approaches 4 of g of x? Well, the left-hand limit is 18. The right-hand limit is 2. So this limit does not exist.